here's something you need to understand about systems of equations. It's one of my favorite things to teach because there's so many real-life applications of systems of equations. Okay? So you might think I'm getting too excited. Sorry, not sorry. Okay? So what does this mean, a system of equations? Yeah, you could tell that by your context clues, right? It's plural. So it's more than one equation. Okay? So today we're going to primarily be talking about linear equations. Two variable equations, x and y. Okay? If I have two variable equations, so a linear equation, and I have two of them, you know that because it's plural, right? How many different ways can I have solutions? Where is the solution to a system of equations? So if I'm graphing the two equations, the solution is where they cross. That's exactly right. Okay? The solution is where they cross. Okay? So we need to talk about what that can look like, because it can look like different things. Okay? I can have one line that goes like this and one line that goes like this. Well, where's the solution? Right here where they cross. This is the solution. X, Y. I don't just draw the lines and circle where they cross. I have to state where they cross. I have to write down where they cross because this right here is the solution. The point of intersection. Where is the solution? The point of intersection. One more time. Where is the solution? Okay. Any questions about that? Is that the only possibility, though? Well, hopefully you would say no because I have two more graphs drawn, right? Using context clues. What about this possibility? Why? No solution because they're parallel. Just like you said. Okay, good job on that one. Is there one more possibility? There's one. Oops, wrong color. Here's the other one. So that's what most people like to say, right? Because that makes sense to you in your head. But think about it for just a second. Okay? I totally understand why you want to say all real numbers. Okay? Because you're saying any number that we put into this system of equation works, right? Except, how many numbers are there as part of the solution? There's one point, but there's two values, right? So we can't say all real numbers. What we have to say is infinitely many solutions. Earlier they said, what if we can't spell infinitely? And I said, learn. Question so far? You good? So what happens if we actually have a system of equations we have to solve? What about this system of equations? I don't know why it's pink and when I put my hand there it goes back to white. I don't understand that. Maybe because my bulb is going out, except it's all the way pink on my computer. So if that's bothering you, again, sorry, not sorry, because I can't do anything about it. Okay? So typically there's this little pretty brace on the side of it. That kind of lets you know for sure that it's a system of equations, okay? Got it? Today you need to know two ways to solve this system. The first way is by graphing it. Right? Just like we just talked about the different solutions you can possibly have. We need to find the solution by graphing. Well, in order to solve these by graphing, what do I need to do? Get y by itself. Okay, I have to isolate the y. So in the first equation, the way I'm going to do that is by subtracting x. So I get y equals negative x plus 5. You want to go ahead and graph that one? How do I graph it? Oh, you guys are scaring me a little bit. What's the y-intercept? 5. So on the y-axis I go 1, 2, 3, 4, 5 and put a dot. What's my slope? What's my slope? What's my slope? Negative 1. Okay? Negative 1 over 1. Negative 1, if I go down, I have to go positive 1 here. Negative 1, positive 1. I'm going to go ahead and put all the dots that I possibly can because that makes it seeing the line a little easier. Can I go up 1? As long as I go left 1. Okay? I'm going to be honest, that scared me a little bit, guys. Did you just forget, or did you just not want to talk to me today? Rude. Oh, you forgot. Okay, that's fair. What about the second equation? What do I do for it to solve for y? First step is subtract 2x from both sides. Once I subtract 2x from both sides, I get 3y equals negative 2x plus 13. What do I do now? Divide everything by 3. So y equals negative 2/3 x plus 13/3. Guys, if I'm looking for y-intercept, 13/3 doesn't mean anything. What do I need instead? I need a mixed number, don't I? What's the mixed number that goes with 13/3? 4 1/3. So my y-intercept is up 1, 2, 3, 4, and a little bit more, a third, right? So from here I need to go where? Down 2, 1, 2, over 3 to the right. Down 2 over 3 to the right. Down 2 over 3 to the right. Or up 2 over 3 to the left, right? Like that. And then I just hope it crosses somewhere. Can you see where it crosses? Right there. So is that my answer? You have to write the point, right? What's the point? 2, 3. Now, am I sure that's correct? 2 plus 3 equals, does 5 equal 5? 2 times 2. 4. 3 times 5. 3 times 3. So 4 plus 9, does 13 equal 13? Are we sure that this is the answer? Yes, we are now, aren't we? Okay. Any questions about solving a system of equations by graphing? Is there a way we could check 100% to make sure it's exactly right? With your calculator, okay? And in fact, on your homework, I'm going to ask you to do just that. You're going to graph it on the graph that you're given, and then you're going to come to your calculator to check, okay? I want a new graph. My first equation is, oh, look, I already put it in y equals, so that's perfect. Pardon? Tab? Tab? So negative x plus 5, enter, and it graphs it for me. Mine's blue. What color is yours? Okay, good. Then tab to get another equation, and I want negative fraction 2/3 x plus fraction 13 over 3. Does yours look like mine? How can we tell for sure that that's 2, 3? Do you remember? Can I walk you through just in case you don't remember? Do you mind if I walk you through just to make sure? Menu, analyze, intersection. So I'm just choosing number 4. Now look what it says, lower bound. That means there's a lot of situations where we're going to have more than one intersection. Okay? In this particular case, you know we only have one, right? Because it's 2 lines. But there are situations that we will face this year that we're going to have more than one intersection. So it wants you to put it on the left-hand side of the intersection. And then click that middle button. And now it says upper bound, so we want to move it to the right-hand side of that intersection and push the middle button. And then it says right here, I'm not sure if you can see it, so I'm going to grab it and pull it up a little bit, what our intersection is. Got it? What I don't want you to do is graph it on your calculator and then try to transfer that to the graph on your paper. I want you to graph on your paper first and then check with your calculator. Do you understand? Any questions about that? Okay? So solving by graphing is the first way we need to know how to solve a system of equations today. Are you comfortable with solving by graphing? Okay. The second way you need to solve a system of equations is by substitution. Okay? Now, none of this is new. This is all review from Algebra 1, but it's been a while. So do you mind if I cover this for you real quick? It's okay? It's okay? Oh, you don't mind. Okay, excellent. I'll go ahead and do it then. If we're solving by substitution, remember the first thing we want to do is we want to find a variable that's by itself without a coefficient if possible. Okay? Because we're trying to do it the easiest way, right? I could literally choose any of these 4 variables to solve for, to isolate, but if I want to do it the easiest way, I want to choose one that doesn't have a coefficient. Or, if you think about it another way, it has a coefficient of 1. Does that make sense to everyone? Okay. Now this isn't a particularly hard problem, so I could easily choose one of these, either x or y down here in the second equation. But choosing one of these 2 will be easier, so I want to choose one of those 2. Okay. Now, most of you, for the record, when I ask you to choose a variable to isolate, you automatically choose y. Because that's what you're so used to. Right? Solve for y so we could graph it, right? Except we're not graphing this, are we? We're solving this by substitution. So if you guys don't mind, what I would like to solve for is x, because you're not used to doing that. You okay with that? So if I'm solving the first equation for x, what do? I subtract y from both sides, right? When I subtract y from both sides, what I get is x equals 5 minus y. Now some people freak out because this isn't in slope-intercept form, right? I never said it had to be in slope-intercept form, right? There's not a slope-intercept form when we're not graphing. We're not trying to graph it. We're just trying to substitute it. So to me, 5 minus y is a lot neater looking than negative y plus 5. You see what I'm saying? So it doesn't matter what comes first, the constant or the variable. It doesn't matter. We're not trying to get this into some specific form, if that makes sense. Yes? Now, I know that x equals 5 minus y. Is there another x somewhere that I could substitute that into? Right here, right? So I'm going to start writing the second equation. 2. But instead of writing x, what am I going to write instead? Exactly what I know x equals. So 5 minus y plus 3y equals 13. Now, why is this so helpful? I only have y's now. I can combine them and solve for a y, can't I? I can't combine x and y to try to solve for one or the other, can I? But now that I've substituted this into the second equation over here, I only have one variable left, which is the y's, and I can combine those and solve for that y. Okay? Now what? Distribute here and here. 10 plus minus 2y plus 3y equals 13. How comfortable are you at doing multiple steps at a time? Can you do 2 steps at one time? Yes? So I'm going to go ahead and subtract 10 from both sides, and I'm going to combine my y's at the same time. What's negative 2y plus 3y? Y equals 3. Because 13 minus 10 is 3, correct? So now I'm done, right? What? Oh, man. I know I'm looking for a coordinate point, right, as my point of intersection. Y equals 3 is not a point. It's just a y value, isn't it? So I could go take this y and put it here, couldn't I? Wait, time out. I could take this y and put it here, couldn't I? Yes, I could take this y and put it here, couldn't I? Is that the wisest choice, one of these two? How about if I just plug it into this one because I already have x solved for? Isn't that what I'm trying to find? So if I take this and put it right up there, I have x equals 5 minus y, which I know is 3. X equals 2. Now I'm done? Ugh. What do I have to do? I have to write it as an ordered pair, don't I? Good job. Okay? What's my answer? 2, 3. That is my solution. Will there be a time that I don't write it this way as my answer? Yes. I will make it very clear when that time has come. Promise. Okay? How do you feel about substitution? What if there's not one with a 1 as my coefficient? No. What if there's not one? Talk to me about it. What should you choose instead? The smallest. Okay, if this was a 4 and this was a 5, what would we choose? I would choose the 2. Right? If this was a 4 and this was a 5 and this was a 3 and this was a 2, I'd probably choose this one. Not the 2, but I'd choose the x to solve for. Right? So sometimes it's a matter of figuring out which variable to solve for first. And sometimes it's a little easier than that because you have easy variables to solve for. Got it? Anybody have any questions?